In lesson 3-7, we'll be working a little bit with geometry. We'll be finding distance on the coordinate plane. We're going to use what we've learned here about Pythagorean theorem to find the distance between 2 points on a coordinate plane. But first we need to spend a little bit of time talking about a coordinate plane and reviewing how it works and how we list and write the ordered pairs and everything like that. So for starters here, our little example, notice we have quadrant 1. We write 1 with a Roman numeral I, and then we go counterclockwise to quadrant 2 and counterclockwise to quadrant 3, and then we finish at quadrant 4. So just notice that we do have this counterclockwise motion when we're counting for our quadrants, and also notice that quadrants are written with a Roman numeral. Next thing I would like to talk about is here, this is one of the points, -2, -4, and it's important to remember that the x value always goes first and then the y value goes second. And where I'm getting that x value from is here is the x-axis. The x-axis goes across horizontally, so you can kind of think x across. And the y-axis goes up and down. You can kind of think y to the sky. Y rhymes with sky, and the y-axis shoots up to the sky. So you could think of that. Just remember that x is always first. So you're always going to go left and right first, and up and down second. So -2, -4 means that you start at the origin. The origin is called the point here. We would say 0, 0. You start at the origin, you go left 1, 2, down 1, 2, 3, 4. So that's -2, -4. So on to example 1, it tells us to name the ordered pair for point A. So we're going to write A, and you always have parentheses when you name an ordered pair. And we start at the origin, and we're going to count right 1, 2, and then up 1, 2, 3.5. So right 2, up 3.5 gets you to point A. One other thing I'd like to point out about our quadrants is that in quadrant 1 we're always going to be a positive x and a positive y value. Quadrant 2 we're going to have a negative x and a positive y value because we're going left and up. Quadrant 3 we're going to have a negative and a negative x and y, so you can kind of see -2, -4, you're going left and down, both negative directions. And then in quadrant 4, you're going to go positive x and negative y, so positive, negative. So in this one, we know that this is quadrant 1, so it should be positive, positive. So both of our values here are positive. Example 2 for point B, again, we start at the origin, so I'm going to label my point B. And I'm going to go left 1, 2.5, so that's -2.5. And I know that I'm in quadrant 3, so it should be negative, negative, down 1, 2. So since we're going down, that's -2. And again, this is quadrant 3, and you can just say QIII. And since this point is in quadrant 3, we knew it was going to be negative, negative. You could also go back and write that this is quadrant 1, and just to label, so that way we're identifying what quadrant we're in as well. For example 3, they want us to graph and label the points. So 2 steps here. The first step is graphing. Start at the origin. We're going to go left 3, 1, 2, 3. And then we're going to go up 2.75, 1, 2, and 0.75 would be about 3/4 of the way. And so there we graphed it. Now we need to label point J. So labeling is just simply writing the letter down. And if you wanted to, you could also list that this is quadrant 2. So that way we can continue to review our quadrants. For example 4, we're going to graph and label point K. So first we're going to start at the origin. And once we're at the origin, we're going to move to the right 4. So 1, 2, 3, 4, and then we're going to go down 1 and 1/4. So we'll have the point right about there. And now we need to label it. This is point K, and we are in quadrant 4, which is IV in Roman numerals. And we're finished with that one. Now with example 5, we're going to start actually finding the distance between the 2 points. First we were just reviewing how to graph points on a coordinate plane. So here we're going to have 0, 2, so we're at the origin, 0, and then we're going to go up 2. Okay, so that's one of our points. So we're going to go right 5. So 1, 2, 3, 4, 5, and down 1, 2. Okay, and then we want to draw as straight a line as possible here between our 2 points. And what we need to figure out is how far it is from this point to this point. Well, it's really hard to count distance on a diagonal line. So what we're going to use, and I already kind of hinted at this, is we're going to be using the Pythagorean theorem. So what we need is a right triangle. So do your best in drawing in your lines and know that this is a right triangle. So now we need to figure out how far it is. 1, 2, 3, 4. So a distance of 4 there, which we know from 2 to -2 is a distance of 4. And from 0 to 5 is a distance of 5. So we can graph it and count it, or we can just figure it out by looking at the values. So we go 1, 2, 3, 4, 5. So we know then that this distance is going to be c in Pythagorean's theorem. So a squared plus b squared equals c squared. And I know I'm going to have 4 squared plus 5 squared equals c squared. So 16 plus 25 equals c squared. And that ends up being 41 equal to c squared. So now we need to take the square root of both sides. And if we need to jump to a calculator for this, since 41 is not a perfect square, we're going to do 41 and we will find the square root, which is about 6.4. So we're going to say that c is about equal to 6.4 units. And it is important that we say units. The reason why we want to include the letters UN here is for our units. We are talking about a distance and nothing's labeled here as for centimeters or inches or anything, so we'll just include UN for units for this problem. In example 6, we need to graph these points again, start at the origin, -3, 1, 2, 3, and 0. So we're right on the x-axis with that point. And then we're going to go 3 to the right, 1, 2, 3, down, 1, 2. Okay, and again, connect those two lines as straight as you can. This will be our hypotenuse. And then we need to make our right triangle in order to find our distance. So do the best with your lines. That wasn't the straightest there. So we know we're going down 2 because from 0 to -2, that's a distance of 2. And then from -3 to +3, we know that's a distance of 6. We can also count it, 1, 2, 3, 4, 5, 6. So again, we're looking for the hypotenuse here, c. So we'll go ahead with 2 squared plus 6 squared equals c squared. From our formula, a squared plus b squared equals c squared. So we'll go with 4 plus 36 is equal to c squared. And so 40 equals c squared. Now we want to find the square root of both sides. So we know that c is equal to, and last time we were at 41, so this will be pretty close here. So we're going to go the square root of 40 is about 6.3. So we're going to say about 6.3 units. Don't forget to include those units because we are talking about a distance. And for example 7, we're going to go ahead and do -3, 4. So left 1, 2, 3, 1, 2, 3, 4. And then we're going to go to the right 2, 1, 2, down 1, 2, 3. Okay, and go ahead and connect your lines, your points. We can make this a little bit straighter. And then we want to remember that this is a right triangle, and that's what's allowing us to find out the distance c between those 2 points. So if you look at your values here, y values, we have a difference of 7. So we know this should be 7. 1, 2, 3, 4, 5, 6, 7. And then down here, 1, 2, 3, 4, 5. You can count it, or you can just say, okay, between -3 and 2, there's a distance of 5. So now we're going to use Pythagorean's theorem. So 5 squared plus 7 squared equals c squared. And so 25 plus 30 plus 49. So 25 plus, 49 equals c squared. And then we'll combine those two to get 60, 74 equals c squared. And then we'll take the square root of both sides to get c is equal to, and if we need to use our calculator, we know it should be between 8 and 9, but we'll find out 74. Square root of 74 is about 8.6. So C is about equal to 8.6 units. And that's one way to find the distance between 2 points on a coordinate plane, is using the Pythagorean theorem, because any right triangle will follow the rules of the Pythagorean theorem. That'll be the end of part 1 examples. Be sure to check the tutors online if you need any other help or want to see more examples. And also be sure to check out the answer keys to the worksheet and or the step-by-step homework helper for all the odd number problems in your book.